All right, greetings YouTube, beautiful mind here. So we have the following question that comes in from college algebra. We're asked to solve the inequality and write the solution set in interval notation. Okay, so I usually like to start by getting a copy of the original. So the original question that we have, let's see, is x plus 6, parentheses, times x plus 1 times x minus 9 is strictly less than 0, right? Okay, so let me think about this. So this is kind of an extension of the zero factor property. If we apply the zero factor property, if this were an equation, if we were to treat it like an equation and get the key numbers, basically we would set like x plus 6 equal to 0, we would set x minus 1 equal to 0, and we would set x minus 9 equal to 0 and solve. And we would get 3 solutions, right? So you can actually look at this and get your solutions fairly quickly as far as the key numbers. From here, the key number we're going to get is what? X equals negative 6. From here, x equals negative 1. And from here, x equals 9. So those are our key numbers if we solve those 3 equations that I mentioned a moment ago. What we want to do is take those solutions and plot them on the number line. So, for instance, say this were negative 6. This would be negative 1. And this would be 9. So, for instance, if we were to look at the graph of the original, it's basically an S-shaped curve. It's like a S. Leading coefficient is positive, so the right hand should go up. So now you don't really need to know this to do this, but it helps if you know it. So if we were to plot the above 3, and if we consider, like we would look at the 2D graph, we would anticipate a graph that will behave something sort of like this. The leading coefficient is positive, so we would anticipate the right-hand side to go up. Since it's odd, the left-hand side goes down. And then it should behave something like this. So basically it's saying, when is this graph less than 0, or when is the graph below the x-axis? So if we're anticipating a graph as we see, we're anticipating to the left of negative 6 and between negative 1 and 9. But you don't need to know this to solve this. So once we have our key numbers, all we do is choose a test point, for instance. So to the left of negative 6, we're going to choose negative 7. All right, I just chose a number to the left of negative 6. If we plug it into the original, this is going to be negative, this is going to be negative, this is going to be negative. So a triple negative, negative times negative times negative, is ultimately, so that means everything to the left of negative 6 is going to be below the x-axis. It's going to be negative. Let's choose a number between negative 6 and negative 1. Let's choose negative 2. Okay? If we plug in a negative 2 here, that's going to be positive, that's going to be negative, and a negative. So a positive times a double negative is positive. So everything between negative 6 and negative 1 is going to be positive or above the x-axis. If we choose a number between negative 1 and 9, I'm going to choose 0 because 0 should be the easiest number to choose in this case. This is going to be positive, positive, and negative. So positive times a positive times a negative is ultimately negative. If we choose a number to the right of 9, say 10, so if we plug in 10, this is going to be positive, this is positive, and this is positive. So positive times positive times positive is positive, right? So again, the original question is asking, when is this original polynomial negative or less than 0? So we confirmed our intuition by choosing points in those intervals. So our solution set is basically talking about all the numbers to the left of negative 6 and between negative 1 and 9. So then the far left, so then the solution is going to be, the far left will be negative infinity up until negative 6. And then we're also talking about the numbers between negative 1 and 9. Because the original is strictly less than, which means we cannot be equal to 0, all of these grouping symbols are going to be parentheses. Infinity always gets a parentheses. These are going to be parentheses, and we're going to combine it with the union. Okay. So again, what we're saying is that any number in this interval is going to make the original true. I don't even know how I just got that option. Oh, that's interesting. That's good to know. I just learned a new trick. Awesome sauce. Okay, I use that going forward in certain scenarios. Okay, so I got this negative infinity to -6 union -1 to 9. So it looks like the result here would be C. Okay, so just give that a go and let me know how this works for you. And on that note, we're going to end this session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.